Chemistry Paper 1 for the year 2018. We present Form 3 work as tested in the year. Welcome. We shall begin this video with question number 4. Question 4 was borrowed from a Form 3 topic by the name sulfur and its compounds. So we are told in question 4, one of the allotropes of sulfur is rhombic sulfur. The examiner expected the candidate to name the other allotrope. So here, the other allotrope is monoclinic sulfur. Monoclinic sulfur is also called beta sulfur, or we can also call it prismatic sulfur. So any of those three names would give ourselves the first mark. In part B, we were asked to now draw a diagram to show the shape of the allotrope that we have named. So monoclinic sulfur is in the shape of hexagonal prism. So here we are. A candidate would draw something that looks like that. For the next mark, we proceed now to part C of the question. Part C of question number 4 asked us to write an equation for the reaction between concentrated sulfuric 6 acid and sulfur. And what we know is that concentrated sulfuric 6 acid, which is in liquid state, would actually oxidize. It would oxidize sulfur to sulfur 4 oxide. So we shall balance with a 2 on our concentrated sulfuric 6 acid, a 3 on the gas, and a 2 on water for that 1 mark. We proceed to question number 6, which was borrowed from gas laws. For 1 mark, we were asked in part A to state the Graham's law of diffusion. And here, Graham's law states that rate of diffusion of any gas is inversely proportional to the square root of the density of the gas. Square root of the density of the gas, of course, at constant temperature and pressure. This would be good enough for 1 mark. Moving to part B, we are told to explain why a balloon that is filled with helium gas would deflate faster than that of the same size that has been filled with argon. So here, a candidate was expected to have known that helium is less dense than argon. Being less dense than argon, it therefore diffuses. Helium would therefore diffuse out of the balloon. It would diffuse out of the balloon much faster than argon would do. And that is what makes our balloon that has been filled with helium to deflate faster. So it was 2 marks. 1 mark for mentioning helium being less dense than argon, and the next mark for the rate of diffusion out of the balloon of helium being faster than that of argon. Let's move to number 7, testing the mole. 30 cubic centimeters of aqueous sodium hydroxide solution containing 8 grams per liter of the same were completely neutralized by 0.294 grams over dibasic acid. The question asks us to find the relative formula mass of the dibasic acid. Now, first thing to be done here is to write an equation for the reaction between sodium hydroxide and the dibasic acid. Dibasic acids are generally represented as H2X. So if you react this, we are supposed to get a salt of sodium X and water, because this is a neutralization reaction. From here, we shall balance with a 2 on the alkali and a 2 on water, giving us mole ratio between the base and the acid to be 2:1. Once we have written the equation, we would proceed to get now the molar mass of sodium hydroxide. And this we know, 23 added to 16 added to 1, we get 40. That would give us the first half mark. From here, we shall use the 8 grams per liter of our alkali to get its molarity. So let's proceed now to molarity of sodium hydroxide. And we know from here, we would argue out that given 40 grams per liter, 40 grams is equivalent to the molar mass, I would get a 1 molar solution. But in the question, we only had 8 grams per liter. So what will be the molarity of this solution? We shall do 8 by 1 divided by 40. And that gives a 0.2 molar solution. Now, in the reaction, we did not use a whole liter of our alkali. Instead, we only used 30 cubic centimeters. So the next step was for the candidate to calculate moles of sodium hydroxide used. And here we would do 30 cubic centimeter that were used times molarity 0.2 divided by 1000. That would give us 0.006 moles. Before we proceed to the acid, let us mark this work first. So having scored half mark for molar mass, we would give another half mark for the division by 40. We would give another half mark for multiplication by 0.2 and then divided by 1000. Let's now move to our dibasic acid by first finding moles of it that were used. And this is easy. We would use the mole ratio 2:1. So here, moles of acid used would be 0.06 divided by 2. That would give 0.003. And we would score another half mark for that. Then finally, we are told that the mass of the acid were 0.294 grams that were used. So these were equivalent to the number of moles that were used. So if 0.003 moles were equivalent to 0.294 grams, getting molar mass would mean that we find the mass of 1 mole of our acid. It would be how much? Cross multiplication gives 1 by 0.294 divided by 0.003. And that gives us 98 as the relative formula mass of our acid. Division by 0.03 half mark, 98 half mark. Total 3 marks. That leads us to question number 12, testing on organic chemistry 1. When a thin gas is compressed at a high temperature, a solid is formed. This is polymerization of ethene. So the solid formed here is the polymer of ethene that we call polyethene, or we can go for the chemical name of polyethene. For 1 mark. Part B is asking us to explain why it is not advisable to allow our polymer to accumulate in the environment. We have 3 reasons. 1 is that polyethene is non-biodegradable. Non-biodegradable. There is an A here, non-biodegradable, which can also be substituted with polyethene pollutes the environment. Apart from this, we also know that polyethene accelerates fires, which can also be replaced by the word highly flammable. And finally, we know that polyethene or any other plastic produces poisonous fumes when burnt. So any 2 of those 3 would give ourselves the 2 marks. We move on to question number 14, testing on chlorine and its compounds. Figure 3 shows a setup used by a student to prepare dry chlorine gas in the laboratory. So looking at the setup, we needed chlorine gas, which we know is produced by oxidation of concentrated hydrochloric acid. Of course, common oxidizing agents used here are manganese 4 oxide, or we can also use potassium manganate 7. But instead of oxidizing our concentrated hydrochloric acid, this student now used concentrated sulfuric 6 acid with sodium chloride, which, as you know, will never produce chlorine gas. Instead, we shall produce hydrogen chloride gas, which goes against what the examiner or what the student intended to prepare. So the first mistake is to use the wrong reagents in the generator. 2, calcium oxide is a basic drying agent, and we are introducing an acidic gas of chlorine to it. So again, wrong drying agent. And lastly, we know chlorine gas is denser than air and can never be collected by upward delivery. So the examiner was asking us to identify 3 mistakes and give a reason for each. The first one was wrong reagents. And we are saying that concentrated sulfuric 6 acid, let me use abbreviations, concentrated sulfuric 6 acid and sodium chloride cannot produce chlorine gas. Half mark for the correct mistake, half mark for the explanation. Secondly, we had a wrong drying agent, and we are saying that calcium oxide will react with chlorine. Half mark for the mistake, half mark for the reason. And lastly, we used the incorrect method of gas collection. Incorrect method of gas collection because chlorine is denser than air. Half mark for the correct mistake, half mark for the reason. Very well put. We proceed to question number 27, testing on nitrogen and its compounds. Ammonium hydrogen phosphate with this formula here is a fertilizer used by farmers to boost their crop production. Part A asked us to calculate the mass of element phosphorus in a 20 kilogram packet of our fertilizer, ammonium hydrogen phosphate. So here, the first piece of information that the learner was expected to have found out is the relative formula mass of our fertilizer, ammonium hydrogen phosphate. So here we shall have 14 for nitrogen multiplied by 2. We add these two, 1 for hydrogen multiplied by 8 because it appears here 8 times. We shall add to 1 for the hydrogen here, added to 31 for phosphorus here, and added to 16 for oxygen multiplied by 4. Doing this calculation is getting or giving us 132 for the first half mark. From here, we would go ahead to find the percentage contribution of phosphorus in our fertilizer. So, percentage of phosphorus in our ammonium hydrogen phosphate. Phosphorus is contributing 31 out of the 132 that we have calculated, and we shall multiply this by 100. This is giving us a percentage composition of phosphorus of 0.2348%. That would give ourselves the next mark. And we are now asked to find the mass in a 20 kilogram packet. So a candidate would go ahead and get now the mass. Would be the percentage composition multiplied by the mass of the packet, which was 20 kilograms. This is giving us 4.6969 kilograms. Half a mark for the answer, half a mark for multiplication by mass of the packet. In part B, we are asked to state one advantage of ammonium hydrogen phosphate over urea. So you realize that this is supplying nitrogen and phosphorus as well, but urea here would only give us nitrogen. So the answer here is supposed to be that ammonium hydrogen phosphate, there we are, produces or supplies both nitrogen and phosphorus. These are essential minerals needed by our plants. Okay, so our first fertilizer provide or supply both nitrogen and phosphorus to crops, while urea supplies only nitrogen. That would be the advantage of our first fertilizer over urea. We finally look at question number 28, which tested on the mole as we end our video. And we were finally asked to distinguish between empirical formula and molecular formula of a compound. Now, we all know that empirical formula will only show the simplest ratio. So the marking point here is simplest ratio for the first mark of the moles of atoms, of of different elements. of different elements in a compound. That is the meaning of empirical formula. While when you come to molecular formula, we now give the actual number. The marking point is actual number for the next mark of atoms. Actual number of atoms of various elements present in one molecule of a compound. That would be the difference between empirical and molecular formula of a compound. And on that note, we end our video where we have reviewed Form 3 syllabus as tested in the year 2018 Chemistry Paper 1. Please keep it the Kenyan Teacher for more of such insightful reviews.